Welcome to the video. We have studied YAML syntax. Let's move to a real Catalyst configuration file. The library reads YAML file and transforms it to the dictionary. There are only 5 main sections of it: model params, args, distributed params, monitoring params, stages. The section named stages is huge. It contains other child sections, which we'll investigate further. Let's start from the section named model params. As it follows from the name, here we provide a model name and its parameters. A required parameter model must be specified. That is the class name, which must be registered in the Catalyst contrib registry. There are 2 methods for that. The first, we can use a decorator registry.model while defining a class and import the model in init.py. The second, we can register the model explicitly via the same method as for the decorator, registry.model, which requires the registering class. Other parameters which have been set in model params will be passed to the constructor of the model. Arg section helps you to choose default parameters for a command getlistdl run. If you provide the same options running this command, they will override appropriate ones from the config. You can see a list of them on the slide. Let's consider some of arg's parameters. Expdir sets a folder that contains the file init.py. In contrast to logdir, which specifies only a concrete folder, base logdir acts as a parent folder, which contains subfolders for each run. Subfolder's name contains current time and distributed rank. That is why it's unique. Deterministic and benchmark are the same as for PyTorch. Let me remind that deterministic is responsible for selecting only the cuDNN algorithms which are reproducible. Meanwhile, benchmark tests what algorithm provides the best speed. So, if you are turning on deterministic, you should turn off benchmark mode to make your code reproducible. In terms of distributed params, the name is not correct. Actually, these are apex parameters. Besides options for a distributed training, here we can choose an option for FP16 training. Rank is used to choose an order in a distributed training. syncbn enables synchronized batch normalization. Op level provides you with an opportunity to run FP16 training. You can see an example of a config which specifies FP16 training. Monitoring params helps to set filters for logging to weights and biases service. For instance, logging every batch or every epoch. The slide content is very clear. We have a rich stages section. There are settings for the technique which is known as staging. The main idea of it: you can train your model in several steps. For example, you pre-train on an external dataset, then you perform the main training cycle. In this section stages, you can choose settings for each stage. Criterion params, optimizer params, scheduler params have the same structure. The name, underline, params works as a key and the name works as a field with a specified class. This class must be registered in Catalyst. If you pass other parameters, they will be transferred to the constructor as always. For example, multi-step learning rate with milestones and gamma can be defined in the following way. A constructor of multi-step learning rate will be called. Milestones and gamma will be passed as parameters. To discover which schedulers, optimizers, criteria are available and what arguments they expect, just open an appropriate folder. For example, for schedulers, open Catalyst contrib schedulers folder and observe. Data params has two purposes. The first one, that is the right place to specify parameters for PyTorch data loaders. Batch size, number workers per GPU scaling, and drop last are transferred to PyTorch data loader. The second one, the parameters are passed to the getDataset method of your custom experiment. GetDataset function returns a dictionary of datasets, so you can construct your datasets with custom image folders, augmentation types, etc. State params is responsible for number of epochs in the stage, metric to decide the beta checkpoint, choice of our goal, either to minimize or to maximize the metric, some additional information to checkpoint data. You need to add a corresponding callback, which outputs the metric you have specified in main metric. Callbacks params helps you to define callbacks. Name 1, name 2 can be replaced by any name you desire. Callbacks can be standard or can be registered in the registry. Moreover, via runState, callbacks can exchange information between themselves, as well as between criteria, metrics, etc. So, you can build a very modular training system. For example, you can observe criterion callback here. Actually, the pipeline is the following. The framework takes a batch from data loader, it searches for keys, features, and targets in the batch. Then it saves the values in runState. Next, it transfers features to your model and saves the predictions in runState by the key logits. Finally, criterion callback takes these logits from runState and computes loss. In the end, I want to tell you how to share parameters across stages. Firstly, define them in the parent stages block. If you desire, the parameters can be changed at any appropriate stage 1, stage 2, etc. Thank you for having watched the video. See you next time.